You're listening to MedX, the Medical Extrusion Podcast. Presented by U.S. Extruders. Extrude with confidence. Custom extrusion equipment designed for you and your application.
Welcome back. Today we're talking about innovations in PTFE coatings for mandrels, pull wires, core wires, and hypotubes. Our guest is Erik Wendehost. Erik is the Director of Sales at Applied Plastics. Applied Plastics is a leading provider of PTFE coated products that are used in the design and manufacturing of advanced catheter systems. Erik, welcome to the MedX podcast.
Thank you, Steve. Thank you for having me. Looking forward to this.
Great. Erik, before we get started, please give our listeners an overview of your background and please tell us a little bit about Applied Plastics.
Okay, for Applied Plastics, we were established in 1953 and our primary product is PTFE Natural coated wire. It's known for its superior lubricity and mold release properties. Most importantly, PTFE Natural is a process, not a product. It's been developed, it's reliable, and it's highly accepted out there in medical devices. Our primary coated products are stainless steel, nitinol, and silver-plated copper. My previous experience was as a director of technical solutions, where I would quote, help develop, and bring interventional catheters to the market. So I'd like to bring a unique perspective on catheter manufacturing to this call and how it relates to mandrels. Mandrels are the foundation of all catheter manufacturing, so starting out with the best mandrel with the best coating is critical to the process.
Excellent. Thank you so much. So let's talk a little bit about further what you said about the mandrels being the starting point for the process. And just for a higher level overview, the PTFE coated mandrels are used as a processing aid for catheter manufacturing to maintain the integrity of the lumens within a catheter shaft during braiding, reflow, and other manufacturing steps such as tipping. The low friction PTFE coating facilitates the removal or release of the mandrel after the catheter assembly is reflowed, right?
That is absolutely correct. And don't forget that PTFE mandrels can also be used for shipping mandrels. We specialize in rounding the ends so that they're safe to insert during final processing. Nothing's worse than damaging your catheter on shipping mandrel insertion. That can ruin a very good product. But for reflow, our release properties are excellent.
I know there are two types of PTFE coatings for mandrels, PTFE Natural and traditional PTFE. Please walk us through the performance advantages of PTFE Natural versus the traditional PTFE coatings.
What's critical to PTFE Natural and what the engineers find the most value in is it's really a two-step process. We'll bring in the wire, we'll prep the wire, and we'll coat the wire. We don't have an intermediate or primary step, which is very critical. What that does is it allows us to have a much thinner coating. This is especially relevant when inserting into very small lumens where tight tolerances are needed. Our coatings can be anywhere from 3/10 on smaller sizes to 5/10 of an inch additional diameter. So adding this coating helps build catheters.
Okay. Talk a little bit about the coating processes. I know looking at your website, there's an automated coating process and then more of a manual spray coating process. Why would you use one over the other?
For an automated process, it's more cost effective, obviously, and you can get more consistency and tighter tolerances, but they are size limited. We can only do automated processes for smaller sizes. When you switch over to manual coating, it is operator dependent. However, our operators are very highly trained. We have developed processes, we have developed measurement techniques to ensure that these mandrels are properly coated. And most importantly, the manual spray mandrels, they're usually a little bit more expensive. These are anything from step mandrels to groove mandrels to anything that takes a form or a shape. So manually spraying these things accurately, getting them through multiple reflow cycles is absolutely critical to making cost-effective catheters in the business.
Okay, so the coating process is a more homogeneous process. Are there potential issues with the spray coating where there's potentially pinholes or flaking or cracking compared to the more homogeneous coating process?
That's a good question. So, just like with an automated process, we only prep the wire and we coat the wire. So, there isn't a primer, so you don't have any issues with the primer and the top coat delaminating. And that's common because a lot of times with PTFE liners, PTFE and PBAX jackets do have a tendency to delaminate if they're not processed correctly. So, when we prep the wire and we coat the wire in a one-step manual spray, it makes a lot more sense and it provides a more reliable product. We do have to inspect these things to a high degree to make sure that they come out well, but it's a very well established process and our operators are highly trained. We make good mandrels out there.
You mentioned with the spray process, you might be working with more of a custom geometry, right? How do you handle those custom shapes? Do you work with a partner to provide those non-circular custom shape mandrels?
Oh, absolutely. So the three hardest mandrels to get would be grooved mandrels, would be step mandrels, and to a lesser degree, tapered mandrels. Whenever a catheter engineer sees these three, they get a little bit concerned. We have a very well developed supply network that can source these mandrels. We'll bring them in, we'll apply the best, tightest tolerance coating, and we'll get them out. If somebody is looking to add PTFE coating to an existing stainless steel material, for better release properties. One thing to remember is our coating is among the thinnest in the industry. So you're looking at adding between 3 and 5 tenths of a thousandth of an inch onto these things to try to see if these wires, these mandrels, or these forms can release a lot better. When the mandrels release a lot better, your quality goes up, your
Mhm.
build times go down, and you're less likely to damage a final catheter during a mandrel pull. So it's something we encourage people to try, develop, and we can source these custom mandrels easily.
Okay. Staying in on the topic of custom mandrels, I notice sometimes on a discrete length PTFE coated mandrel, segments of the PTFE are removed through an ablation process. How do you handle something like that? And why would you use an application like that where segments are a PTFE are removed?
Well, what's critical is when you coat the PTFE, even though it's a very thin coating, let's use pull wires as a great example. So when you take a PTFE pull wire and you weld it to a laser cut hypotube ring with a small chamfer cut in, you're going to want to ablate that coating because the coating does have an effect on weld strength. So we will send the material out for coating. We'll keep the wire in stock, low lead times, and when we send it out to the customer, they'll be precisely ablated so they can be quickly welded and uniformly consistent in terms of pull strength.
Let's talk about the durability of the support mandrels after they withstand multiple reflow cycles. What are some of the best practices during the coating manufacturing process to ensure that the PTFE coating will not flake or crack off the mandrel?
Well, the most important part of the manufacturing process is prepping the wire, making sure that the wire is smooth, it's completely prepped, and it's ready for the coating. After the mandrels are coated and they're straightened and they're cut, and of course the ends are rounded and deburred, good practices in terms of a catheter engineer is if you are doing a final cut to length or you're doing any trimming, it's always a good idea to pull the PTFE catheter or pull the PTFE mandrel, put in either a gauge pin or hardened tool steel and do the cuts at that point in time. If you cut consistently on a PTFE coated mandrel, regardless of manufacturer, you're going to make small nicks and cuts, and that can definitely affect your final product. We also encourage IPA wipe downs. We recommend a 70% IPA alcohol wipe down after every single use. You look at particulate and extrusion, anything from barium to colorants can sometimes, or lubricious additives can go to the surface. Those can sometimes show small burn marks. So cleaning mandrels, maintaining mandrels, and being careful with them is critical to manufacturing processes.
Okay. As you might know, there's a worldwide supply chain issue with PTFE inner liners for catheters. And a lot of folks are working on alternative low friction materials for inner liners like HDPE or PBAX, nylon 12 with lubricious additives. Does the use of alternative liners from PTFE impact ergonomics, yields, or cycle times when you're releasing the mandrel from the catheter assembly?
Oh, absolutely. So PTFE liners have been the gold standard for the innermost layer of a catheter for quite some time. There is a supply shortage, and our best guess is it's going to continue through the next year. When you switch to a polymer liner, if you have just a regular stainless steel mandrel, it's going to stick during mandrel process. And most importantly, if you're using a multi-lumen catheter and you have several mandrels, the operators hate doing that. If they're going to have to pull multiple stainless steel mandrels every time they build a catheter, there's ergonomic issues or sticking issues, and there's a potential to damage the catheter. PTFE is critical to building for PBACs, HDPE, or any polymer liners. If you don't have PTFE coated mandrels, they're going to be very hard to remove. It's just a best practice, and we're seeing more and more customers question, do we continue to use PTFE liners? What happens when we switch to a polymer-based liner? And most importantly, let's get some good tools so we can do a very valid DOE to find out if this switch can be made for our current product or any new products. If you can't get liners, you can't build catheters. That's the innermost layer of any interventional catheter out there.
Right. Is there a difference in the gap or the clearance between the mandrel OD and the lumen ID when you're not using PTFE or vice versa?
What I would probably do is ask the customers what size mandrel they're using, and we can source the wire to be slightly smaller. And most importantly, our coating is 3 to 5/10 of an inch. So it's very easy to find. We have a very large stock of wire that we can either produce out of stock or grind down so that we can produce the exact same size mandrel, only PTFE coated. You don't want to change your catheter design. You want to change your tooling so that it's easier to remove, easier to process, and, in case of shipping mandrels, easier to insert. So it's something we can adjust for, we can build, and we can help the engineers on that.
Okay, interesting. Let's turn our attention to pull wire actuated deflectable and steerable catheters that include multi-lumen catheter shafts with auxiliary pull wire lumens. And
Okay.
often those auxiliary pull wire lumens, again, are PTFE lined to promote a slippery surface between the pull wire and the inner lumen surface. Share with our listeners some of the design criteria that's used to determine when a pull wire should be PTFE coated versus when the design might allow for an uncoated pull wire.
Oh, that's a good question. So when you take a look at a multi-lumen construction, if all of the lumens are lined with PTFE, that's more unusual. A lot of times you'll have certain lumens lined. If you're perhaps putting electronic components down the lumen, you really do want a PTFE liner because it's going to give you good wall integrity. Quite often, adding a PTFE liner puts a little bit of extra stiffness into the catheter, so they'll leave the outermost multi-lumen layers unlined. Those are where you put your pull wires through. Our belief, and we're testing this in currently, the coefficient of friction against both materials, PBACs, doped PBACs, and other polymer liners, is pull wires are going to be a lot more easy to install in an unlined catheter, an unlined lumen. And when you take a look at where your biggest or your highest costs in building catheters, assembly is critical. If you can take a couple minutes out of assembly for each step, it's going to be good on performance, it's going to be good on ergonomics, and you're not going to damage the pull wires. The PTFE coating will glide down the lumens quite easily. So I think it's a design advantage right there.
Erik, thanks so much for joining the podcast today. It was very informative, and I'm sure that our listeners feel the same way. Thank you so much.
Steve, I appreciate the chance to talk about our mandrels, our production, and what we can do for catheter engineers. So, great podcast, and keep it going.
Thank you.
Thank you for listening to MedX, the Medical Extrusion Podcast, presented by US Extruders. Please subscribe to make sure you're getting the latest episodes. All links are available in the show notes.